We now want to use our trig identities relationships that we just saw to be able to solve some problems and simplify some expressions. Some are going to be easy, some are going to be hard, some can be done a number of ways. So basically you've got to try and come up with the best way to do this. Sometimes that's easy, sometimes it's not so much. So the first one here, tan of theta times cos of theta. How can we simplify that? Well, we know there's a relationship with tan to be sine on cos, and because we've got cos there, we can go that tan we can simplify. We can't really simplify cos too much in that respect. So sine on cos times the cosine, and then we get them cancelling out and gives us just sine theta. Tan and cosecant, well, we know tan theta's got a relationship of sine on cos, and cosecant's 1 on sine, and we get to a situation where we can simplify and cancel the sine thetas. 1 on cos theta becomes sec theta. So there's our first couple, which are not too hard. Secant theta and cotangent theta, well, we know the relationships and getting them back to in terms of cos and sine. So sec's 1 on cos, cot's cos on sine, and again we can get some cancelling happen. 1 on sine becomes cosecant. Now for 4, we've got to start remembering our main relationships and being able to manipulate it. So we know that sine squared x plus cos squared x equals 1. So if we take sine squared x and subtract it on both sides, then we have this situation where cos squared x can be written by itself, and we get that relationship between 1 minus sine squared x. So having something like that, we can just write it as cos squared x. So we've got to make sure we can manipulate any of our expressions there that we had. Question 5. Well, we know that one. If we took this expression and divided by sine, we got 1 plus cotangent squared x was equal to cosec squared x. So we can apply that to this rule, which we've just got the cotangent squared alpha plus 1 gives us the cosecant squared alpha. So that one was just a straight manipulation, straight forward, as opposed to this one, which had a little bit of manipulation to go on. So be able to manipulate and be able to subtract, add, divide, multiply, and play around with them there. 1 plus tan squared alpha equals secant squared alpha. So again, we're remembering our relationships. This time we've got a 3 plus 3 tan squared alpha. A lot of these ones, be prepared to factorize. So get a 3 out, and we get 1 plus tan squared alpha, and the 1 plus tan squared alpha is equal to sec squared alpha. So that's not too bad once we factorized. This one here, we've got two fractions, and we have to add them. We can't really do much except get the common denominator. Lowest common denominator would be the multiplication of both of those. So we multiply this side by 1 plus cos squared, 1 plus cos alpha. So that's where that 1 plus cos alpha comes from. Multiply this fraction top and bottom by 1 plot minus cos alpha. So that's where this one comes from. And our common denominator is just the 1 minus cos squared alpha plus times 1 plus cos squared alpha, which is the difference of two squares, which makes it nice because that gives us 1 minus cos squared alpha on the theta on the bottom. The 1 plus 1 gives us 2, cos theta minus cos theta cancels, and that gives us 2 on sine squared theta, because 1 minus cos squared alpha theta is equal to sine squared alpha. So we got that manipulation from one of the previous questions. And 2 on sine gives us cosec. So there's our simplification of those two fractions. So look for the fractions, see if you can factorize anything out again. It's always easy to factorize. If you can do that, that makes life easier. But if you can't, then you've got to go back to what we know about fractions. And we know when we add two fractions, we've got to add a common denominator. So we have to go and do that. So that leads us to the next one, where we've got a bit more of a complex fraction. But the idea, again, we can't do much simplification first. We've got to just get a common denominator. So sec theta minus 1, sec theta plus 1, multiply those two. So tan theta gets multiplied by the sec theta plus 1. Tan theta gets multiplied by sec theta minus 1 in the second fraction. Now we can factorise the tan theta out. And so it gives us the two brackets added together, which our 1's cancel. There's 1 minus 1. Sec gives us sec squared theta minus 1, which again is a manipulation down to be able to get tan squared theta. So again, we're using those relationships we had, because we knew tan squared theta plus 1 was equal to sec squared theta. So sec squared theta minus 1 gives us tan squared theta. So we get tan theta times 2 sec squared theta, 2 sec theta. One of the tans will cancel, so sec on tan. And then we can change tan in this line to be sine on cos. And sec theta's 1 on cos, so that's where we get the 2 on cosine. Dividing by a fraction, so we make it multiplication and take the reciprocal. So our cos thetas are going to cancel. Gives us 2 sine theta, which gives us 2 cosecant theta. So what was looking very complex comes down to something that's a little bit more simple. But it's about getting a common denominator, cancelling terms, then being able to get look at our relationships and be able to manipulate them to simplify. This one here is a classic one where we're going to factorise. So cos squared beta minus cos beta to the power of 4, factorise cos squared beta out, gives us 1 minus cos squared beta, which can be written as sine squared beta. So look to factorise where you can. And that's what I would have done with this one, except there's nothing really to factorise. It's close, but nothing really to factorise, and it's plus there, so it's not a difference of 2 squares. So I'm left to expand it out, which is not too much fun. Gives us 9 cos squared a, 2 times the product of those, 24 cos a sine a, the last term all squared, and did the same except with minus in the next term. So we get that expression, which we start to simplify. But the nice thing about it is those two cancel because it's subtraction, and we get 9 cos squared a plus 16 cos squared a gives us 25 cos squared a, and the same thing for the sine squared a gives us 25 sine squared a. Factorise our 25 out. Cos squared a, our a plus sine squared a is 1. Very nice. We love it when we see that expression come up, because that comes down to 1 and simplifies a lot of our expressions very nicely. And that leaves us equal to 25. So again, something that didn't look too nice, even when we expanded it, suddenly becomes very nice once we understand our relationships and be able to do our manipulations of factorising, expanding, collecting like terms, and adding two fractions. So all those basic skills, if we make sure we get those right, allow us to put into play our trig identities and be able to simplify the expressions down to something nice.